Welcome to Trident. Trident Building Systems Incorporated is an industry-leading pre-engineered metal building manufacturer, a certified structural steel fabricator, and certified erecting company by the American Institute of Steel Construction. Trident is a member of the Metal Building Manufacturers Association, the American Welding Society, and Associated Builders and Contractors. Founded in 1986, Trident is headquartered in Sarasota, Florida, and provides competitively priced, high-quality conventional steel and pre-engineered metal building packages throughout the United States and the Caribbean. Trident is unique in the industry as a structural fabricator and the erector of the products produced. As an approved federal supplier, Trident has built an unmatched reputation as a reliable, high-speed, and complete steel construction resource, serving all areas of the construction industry. For nearly 3 decades, Trident has been providing the highest quality buildings in the marine and aviation industries. Trident can design, manufacture, and erect single-span structures in excess of 300 feet. These wide-span structures are perfect for aircraft hangars and indoor training facilities. As experts in the design and construction of dry stack storage facilities, Trident buildings have been a key element in the development of the industry's most recognizable marinas. Trident has pioneered the concept of turning massive dry stack storage buildings into some of the most beautiful buildings in the marine industry. Recently, Trident has been involved in developing the next generation of hydraulic lift door systems for its partner company, Airside Door Systems. The new series of hydraulic lift doors is called HydroLink doors, and will complement a long history of providing top quality doors that exceed client expectations. Currently, Airside Door Systems is in production of one of the largest single-span hydraulic lift doors ever made. It's an Extreme Span Series door. An Extreme Span Series door is a HydroLink door exceeding 100 feet in width. This particular door measures an incredible 160 feet wide by nearly 30 feet tall. In addition to the marine and aviation industries, Trident has been a viable resource in the construction of many schools, manufacturing plants, industrial facilities, hospitals, hotels, and automotive dealerships, as well as a variety of other construction projects. During this video, you will learn more about Trident's products with a portfolio of completed projects, and we'll discuss the difference between pre-engineered and conventional steel systems, with the focus on benefits of each of the different design options. In addition, you will be provided with a look inside the highly efficient operations at Trident's facility for an opportunity to see how structural steel and pre-engineered building systems are produced. But first, we'd like to give thanks to our clients. Here are some examples of the many respected construction companies that have partnered with Trident Building Systems over the years. Thank you. We are often asked, what is a pre-engineered building? A pre-engineered building system is a building structure that consists of pre-engineered, prefabricated building components that are combined together and assembled structurally so that the components work together as one system. Pre-engineered buildings can be as unique as customer needs. A computer-assisted design helps create the building for specific use, whether it's commercial or residential use. They feature a structural steel framework of primary and secondary members, rigid frame, purlins, and girts, on which cladding and roofing components are attached. Suitable thermal insulation can be provided where environmental conditioning is required. One of the most commonly asked questions we receive by designers and builders regarding pre-engineered versus conventional steel construction is, what is the difference and what are the benefits? Well, here is a description of the two. Structural weight. Pre-engineered buildings are on average 30% lighter through the efficient use of steel. Primary framing members are tapered, built-up plate sections, meaning that they vary in depth, with larger depths in the areas of highest stress. Secondary members are light gauge, lightweight, roll-formed Z or C-shaped members. Conventional steel uses primary steel members that are selected from a standard hot-rolled sections, which are often heavier than what is actually required by design. These standard steel members have constant cross-sections regardless of the varying magnitude of the local stresses along the member's length. Secondary members are selected from hot-rolled I or C sections, which are heavier than the like-gauge pre-engineered counterparts. Design. Quick and efficient. Since pre-engineered buildings are mainly formed of standard sections and connections, design time is significantly reduced. Basic designs are used over and over. Specialized computer analysis and design programs optimize the material required. Drafting is also computerized using standard details that minimize project custom details. Design drawings, shop detailing, and erection drawings are supplied by the manufacturer, and approval drawings are usually prepared within 3 to 4 weeks. The expert engineering and design team at Trident design and detail pre-engineered buildings almost every day throughout the year, resulting in faster and more efficient designs. Consultants' in-house design and drafting time is considerably reduced, allowing for more coordination and review, therefore increasing margin on design and construction costs. When designing with conventional steel members, each conventional steel structure is designed from scratch by the engineer, with fewer design aids available to reduce costs. Substantial engineering and detailing time is required on every project. Generalized computer analysis programs require extensive input, output, and design alterations throughout this process. Extensive consulting time is devoted to the design and drafting, as well as coordination and review, often at a significant expense to the client. Each project is a separate case. Engineers need more time to develop the designs and details for the unique structures. More complicated designs will require extensive design and drafting time from the design team. There are benefits to using conventional steel, especially when designing a complex structure and in the design of a high-rise building with repetition or multiple floors. This allows the engineer to stack the similar size framing members that then are reinforced with bracing sections. This allows for the design of exceptional structural heights to be achieved. Limitations. Pre-engineered buildings do have limitations that should be considered. First and foremost would be the limitation of occupied floors. Once you have achieved 3 floor levels, pre-engineered buildings are typically considered uneconomical and conventional steel systems are recommended. There's a point when extremely wide spans and unique structure shapes lend to the use of conventional steel design. Conventional steel systems can be configured to structural depths as assemblies that can achieve massive spans with both flat and curved elements. Conventional steel designs are unlimited when you are working with complexity. Conventional steel is best suited when designing multiple-story buildings, especially with levels that repeat in configuration. So when dealing with complex and tall structures, designing with conventional steel shapes can prove to be more economical. Delivery. The average pre-engineered metal building can deliver between 6 and 8 weeks after approval drawings have been reviewed and returned to the manufacturer. As far as conventional steel, it typically takes 20 weeks from start to finish to design, detail, fabricate, and deliver a comprehensive structural steel package. Cost is always a top priority, and meeting a construction budget is typically easier with a pre-engineered building system. This statement only applies when you are dealing with a design achieved or complemented by a pre-engineered system, and it should be considered that there is typically a reduction in the amount of time required during the erection of the structure. Conventional steel systems may cost slightly more per square foot than pre-engineered building systems, but this is not the case when comparing the time to construct with structural steel versus building with cast-in-place concrete or other options. In most cases, conventional steel design can reduce the overall construction schedule. A well-designed building can be constructed over 20% faster than a concrete structure, and with the flexibility of the steel design, your overall space within the structure can be increased, allowing you to take advantage of the efficiency of an efficient steel design. Structural steel systems often provide much better access for mechanical, electrical, and plumbing trades, and this can have a positive impact on the overall construction schedule and budget.